All right. All right, so next, I've got a slide here that shows it mounted on an M600. You'll notice that the orientation of the laser, you'll see that the laser scanner is at the rear of the aircraft, and that's how you will be flying this on any of the aircrafts. You want that, so the battery compartment is going to be facing forward in the direction of flight. And I think I might have a slide that shows it a little bit better, but this is how we have it mounted. This is what we typically use for our service aircraft currently. Just 'cause it's a very versatile platform. You know, it's got the retractable landing gear, which is pretty nice for this type of system. Fairly reliable for us, so this is what we use. And it's common to, you know, a lot of our customers, as we get more and more drones kind of coming in, M300 is getting pretty popular, at least for the 410, 515 systems. It doesn't really have the payload capacity for the 600 series, unless we drop a little bit of weight on those, but it does well with the pairing with like the 515. We do also do some custom integrations. Of course, if you're interested in that, feel free to contact us, or what we try to do is work with the manufacturer and of course you to get that situated. There's an extra cost to that, but we do have some customers doing that for various drones. So as we get more and more, we'll put out some more material, but we do have a few other platforms that if anybody has questions about, we can maybe talk about, or whatever we need to do about that. So of course you will need to integrate this on your aircraft. This is a typical integration kit for the M600. And you'll see that Ronin mount that has that red lever there. That is the heart of the dovetail mount. And that's typically what, if anything's getting transferred over to like a custom integration, you'll at least have that. It may not look exactly like this, but it'll be similar. Also included in the integration kit is a antenna mast. You can see on the bottom, it's that it has the black antenna with the silver grounding plate there, and then the antenna mast. Also, you can see that it's all mounted on this. There's a black plate that's topped on that M600, and then we have a control box there as well. That's pretty vital to the system. You'll see that's where you're going to get all your messages. You'll know what the system's doing based on that control box. If you're doing integration, if you're getting integration through us, or sorry, I should say, we do the integration if the entire system is purchased through us. So the sensor in the aircraft, at least for the I'll say the M600 and M300. Custom integrations, of course, it's a little bit more of a process, but will also be done by us, or can be done by us. So you do have this dovetail quick disconnect. I should mention that there is some vibration dampening, as you see on the top image there. Those cylinders they'll have some vibration dampening built into those. Oops, I skipped ahead. So we do have this is the mount. So you will need to be careful if you haven't used a mount like this. That lever, you do not have to untighten it all the way. If you do, there is a spring in there that can pop out. So you just have to give it a couple turns usually to untighten it and tighten it. Pretty easy installation. All you do is untighten it and it slides in. I'll have some videos showing that later. System is built mainly to mount on the M600. That's kind of why the shape of the sensor is how it is, just to fit in between the legs, give it a little bit of clearance. You will notice on that bottom right picture there is a braided steel, we just call it the safety cable, safety wire. That's just kind of a extra precaution. If anything were to happen to the mount, you at least have that backup. Not that anything has happened to the mount in the past. It's just kind of that extra precaution. You do have a expensive payload on your aircraft, so having that extra precaution is nice. I've seen some customers have theirs solely mounted to their M600. They'll use these pretty heavy duty zip ties. They're probably about, half an inch thick or so, and have them all in four corners, and they just kind of leave their sensor permanently mounted to the aircraft, and then have that extra safety, kind of just a fail safe, if you will. I will mention briefly, if you are curious about integrations, and I'll be visiting this pretty often, but our knowledge base, which is support.goq.com, is going to have a whole lot of this information that I'm talking about today. So if you ever need to find something, like say the M600, oops, misspelled that pretty bad. If I search this, you'll notice that we've got this. We'll have a video here showing you the integration on an M600. And as we get a bit more drones in, we'll soon be adding the M300 up here, and maybe some of our custom integrations if we do more of those with like a specific drone. We'll be adding that up here. This is also a good place to search for pretty much anything. If you have an issue, you can typically type it in pretty much word for word. You can find a lot of solutions for that. We'll be visiting this website a little bit more later as we go through today. Okay. As I mentioned, with here's that image I was talking about with the direction of flight, with the arrow being the direction of flight, how it's mounted on an aircraft. So controlling the system, there's a couple components that go into that. This being the control boxes as you see here, and UMS, which you'll see in the next slide. We'll start with the control box. So this is going to give you information on what the system's doing. You'll have a battery light, a GNSS light, and a system light. And all the new systems come with this LCD screen. This gives you a bit more information on what the system's doing. So previously we only had these battery GNSS and system lights, so no LCD screen. This is kind of fairly new. It's been out for a while, but it's fairly new. The battery level here, as shown with these colors, doesn't apply as much now with this control box, because you do get a % readout on the screen. So you don't have to. It's not really a range anymore. You've got a certain value that you've got there. GNSS light, of course, just gives you information on that, whether you have it or not. All these lights, for the most part, when they're say initializing, they'll be flashing yellow, and typically are green when they're good to go. But I'll talk more about the lighting chart later. I mentioned the USB storage device. This is the new style here you see, as opposed to the one I was showing earlier. It is just a double-sided USB. It's got a USB-C on one end, which is used for the system. You can also use for file transfer to a computer if you have a USB-C port. It also has a USB-A on the other end, if you have to use that or need that. So like I said, this is what you plug into the system for takeoff and what you'll pull out after. has all the raw data and some configuration files. We'll dive into the configuration files a little here shortly, just to give you an idea of those. If you're doing some typical flights, what we send the unit out as is fairly standard. You can change the settings to if you want the system to operate in a specific way, but you don't even have to touch it if you're pretty happy with how it's operating. And we operate it here when we're doing test flights and doing some service flights as what is standard and sent out to customers. So I did say it has configuration files. These are specific to a single sensor. Well, I'll say one of the two files is specific to a sensor. The core configuration is more of how it's controlled, and this is kind of a generic file that's shared among that sensor type. So all 515s kind of have the same core configuration, minus a few things, and then the system configuration is the other file. This is kind of this is our calibration file, pretty much. You won't be really need to be messing with anything in there. That's sent from us. It's got all its calibration information on it. Like I said, this core configuration is going to have some files that tell the system how to operate, how the laser operates, how the camera operates during a flight. And it's something that if you're going to modify, we do recommend using, actually you can really use any text editor. We typically use Notepad++, something like that. So what I'll do is show you an example of what it looks like on a UMS. Besides this zeroed file here, what you'll have on if you haven't done any flights, are just these top two files: the system configuration, the core configuration. And this is what it'll look like when you have flights. Minus these, I appended these like QC and Cal next to it, so you'll just have one that cycles that look like this. That'll be your flight that has all your raw data in it. That's what you process in say Evo. What I'll do, I may open one of those up here shortly, but I'll go over some of the sections first. Okay. So the core configuration, it is just going to be a wall of text. Like I said, I'll open it up shortly, but you'll have sections like this throughout. Some that you can modify, some that should not be modified. I'll kind of go over some of that, but if it looks like it shouldn't be modified, it's pretty obvious. The ones that don't need to be modified, if you don't stuff like say baud rate or something like that, you don't think you should be messing with, then it probably doesn't need to be. But there are a few values that you can affect. Lever arms can be set in here. I personally don't use this method. I don't find it as effective. There is a slightly better way that I can maybe get into later, where you log into the system itself through its Wi-Fi and set them that way. That's personally how I would do it. That way I know they're set, because that's all this configuration is going to do anyway, is just on the next power up apply these values. But it's I think it's more reasonable personally to set it through the Planix, and I can show that, and then it's also in our hardware user guide how to do that. So there are a couple ways to operate the system. The standard way, what we call proximity mode. I'll just give you the two. We got proximity mode and extended mode. Typically users use proximity mode. There's two reasons you want to use extended, and I'll go over that a little bit. But this is kind of a section where that this gets applied. So you'll see down here that this camera file transfer wide and down. It's typically set to true. So what this is doing is it's going to transfer your images from your SD cards to the UMS after flight. So this is the most lengthy part of that process. It does take up to about 5 minutes for each 15 minutes of flight. So you can imagine that could take a while. So if you have like really long distance flights, or just have a whole lot of flights you need to get done, you can transfer these files over later. You just got to be careful with that, and make sure you are transferring those files at some point within a couple flights, maybe these, because if these SD cards and the cameras get full to its point, there is an auto delete feature which can be turned off, but you got to be careful about that too, because of course if that is off and you don't have any space left on the SD cards or UMS, it of course won't delete it. So there's some trade-offs with that, but you are able to change this camera file transfer off and transfer manually yourself to the cycle. They're fairly easy. I'll show you on the SD cards. If you let me see if I have one here. Let me see what this one looks like. Okay, yeah. Well, you'll see on the SD card, if you do happen to use this method, it'll have individual folders. Each individual folder is typically its own separate flight. In that, it'll have all your images and a TVC file in there. All this is going to tell you the cycle name and the camera it belongs to. That way you can transfer your images into the respected folders on that cycle. But like it says here, if you're flying greater than 30 minutes, it is recommended to change this to false. So if you're flying with anything other than like an M600, M300, something that's got a very extended flight time, you may want to use this, but of course this is all up to you. So section 11, laser configuration. So the only reason you'd change this is if you have like a 600 series, you can change the pulse rate. By default, it's at the higher value, but you can change it. But there are a few reasons you may want to do that, but typically you're going to want that higher repetition rate. You have more points. So section 17, this is a little bit more on the laser. Nothing really you'd change in here. Field of view width may be the only value you want to change if you want to open that up. Default is 120, so we are collecting 120 and further clipping that in the software. But if you want to open that up, maybe you're scanning up the side of a building or something, or maybe a bridge, and trying to get up the superstructure of the bridge or something, you may want to change that. But typically this 120-degree field of view is pretty good. Field of view center is set to 90, so straight down nadir, and should not be changed. Frame rate shouldn't be changed. Baud rate, most of this stuff shouldn't be changed, but there are a few things you can. So I have a question for the Minivux 3 with the 300 kilohertz pulse rate. So this is a tricky subject with the way we operate it, though. Believe that would be selectable, but it's kind of a tricky subject with how they're classifying that 300 kilohertz. I need to read something again to kind of get that better information, but I'll come back to that after maybe our first break. I'll go and read what we have on that, because it is a little bit of a tricky subject with their material and what we we've actually noticed with the system itself. But I'll come back to that. So this section doesn't really apply too much, kind of like what I was mentioning. We do have this LCD readout now where it gives you a percentage value, but you still can change these values of where the low and critical battery percentage. So this is when it changes from green to yellow or yellow to red, the battery light. You can change these. Like I said, you get the percentage on the screen though, so it's not as useful per se. But if you'll notice a light more than you'll notice this on the screen, you of course can change this, or of course just be paying attention to it. So this is the more on that proximity mode. The way that the proximity mode works is you'll have a when the aircraft's powered on, you get your GNSS signal. It'll have its location, and we have a 25-meter distance. So this is an XYZ, so it's 3D distance from that start point. And once it gets out of that 25 meters, it'll start recording data automatically with no input from the user. That's also when it returns into that 25 meters, it'll start doing its wind down process. So this is typically how we use it. You can also turn this proximity mode off completely if you would rather start the system itself. I'll explain a little bit more on that later. If this is off, of course, what you'll need to do is whenever the system is ready to fly, noted by the lighting sequence, which I'll talk about later, you'll hold that cycle button and it'll automatically start. It'll just start recording for you right there. And then you just take off and you just got to make sure to stop it when it lands. Next slide, this is just the auto stop. So this is when it's returning. Same information, it's just when it's returning. I will mention, it has the light sequence in here a little bit, but I'll talk about that when we get to the chart. It makes it a little bit easier to follow. I mentioned the auto delete before. You can change these values. So what this says here is if you get to, you'll see that it has the low threshold is 20%, high threshold is 80. So once it reaches 80% full, it'll auto delete down to 20% full. So it does start with the oldest data. You can change these values or turn it off completely. You just got to be careful if you, like I said, if you turn this off, because of course it's not going to auto delete anything. But there's a lot of space. Each SD card is 64 gigs and the UMS itself is 128. So I mean, you can put quite a bit of data on there before it fills up. Typically I'll do maybe 4 or 5 flights, and or sometimes depending on the mission, I'll go ahead and back up every flight, just throw it on my computer. That way I have that extra copy already saved. So any questions about that? Okay. So I'll go through the basics of planning a LiDAR flight mission. Then we'll take a mid-morning break and then get into Lychee after that. Kind of go through that background.